Good afternoon, everyone. So now we are going to discuss about our fifth unit of our digital electronics, that is working of sequential logic circuits. Those are registers and counters. Okay. So in our last classes already we have seen some sequential logic circuits, basic sequential logic circuits. So what are the basic sequential logic circuits? Flip-flops. Okay, RS flip-flop is over and also JK flip-flop is over with the help of D flip-flop, data or delay flip-flop is over, and also T flip-flop is also over. Okay, and while coming to the basic theme of sequential logic circuits, these are the circuits are used to provide the function of storing. Okay, so here basic element of sequential logic circuit is what? Flip-flop. So what is the main use of flip-flop? It is used to store one binary bits. Okay, and while coming to the sequential logic circuits, so in our last class we have discussed about flip-flop. What is meant by flip-flop? It is a bistable multi-vibrator. Okay, it is a bistable multi-vibrator. And why it is called bistable multi-vibrator? It consisting of two stable states. What are the two stable states? One is flip and other one is flap. And while coming to the construction, it is consisting of AND gates. Okay, and while coming to the state of the flip-flop, if we apply the set input is equal to 1, the normal output Q is equal to 1. Why? Because it having two outputs, both outputs are complemented to each other. Okay, and if S is equal to 1, here we are getting Q is equal to 1. If R is equal to 1, we are getting Q is equal to 0. So that condition is called what? Reset condition. Okay, that condition is called reset condition. And see here, while coming to the next flip-flop, JK flip-flop. So JK flip-flop is also used to store the one binary bit type of SR flip-flop, but the JK flip-flop is designed to eliminate the old condition in RS flip-flop. And our next flip-flop is what? Master-slave JK flip-flop. So master-slave JK flip-flop is designed to eliminate race around condition in the JK flip-flop. And what is meant by race around condition? If we are applying both inputs are high in JK flip-flop, that means J is equal to K is equal to 1. The output is not in hold condition or not constant. It must be try to attend 0, but it back forth to try to attend 1, but it not able to attend 1, it back forth to 0. Means the output is flying in between 0 and 1. It try to reach the level 0, but it is unable, so it come back to 0. This condition is called what? Race around condition. So to avoid this race around condition, we are already developing JK circuit, master slave JK flip-flop. In master slave JK flip-flop, two flip-flops are used. One is called master, other is called slave. So the main inputs are applied to the master and the output of the master is connected to the slave. And final output, having two outputs, we are collecting from the slave. Okay, and in the master, the clock pulse is main clock pulse is applied to the master, and the output of master acts like a clock pulse for the second one. So this is the diagram of master slave JK flip-flop. Okay, the clock pulse directly given to the master, but through inverter it is given to the slave. If master is in active condition, slave is in disable condition. If master is in disable condition, slave is in active condition. So in this way it will avoid the race around condition. So next remaining two important and simple flip-flops are D flip-flop as well as T flip-flop. While coming to the D flip-flop, it is called data flip-flop or delay flip-flop. Okay, what it is called? Data flip-flop or delay flip-flop. So why it is called data flip-flop means whatever the data we are applying across the inputs, that must be as it is passed to the output. And how many number of inputs it having? Only one input is there in data inputs and two outputs are there, Q and Q bar. If we are applying input 1 at data, the output Q is also 1. If we are applying 0 at data bit, the output Q also is equal to 0. The output Q also is equal to 0. And all flip-flops are synchronized with a clock pulse only. That means what? By the application of clock pulse only, with the application of clock pulse only, the output is changed according to the input. Means what? If D is equal to 1, Q is equal to 1 after the application of clock pulse only. If clock pulse is not there, means even though we are applying the input, the output is not appeared. So in this way, the input and the state of the output is synchronized with the clock pulse. And this D flip-flop is also called delay flip-flop. Why it is called delay means, here this flip-flop will not change the input. As it is, it passes the input to the output, but after some time. If we apply the clock pulse after 5 minutes, then after 5 minutes the output must be occurred. Means what? After some delay, after application of some delay only, the output is produced. That's why this flip-flop is called delay flip-flop. Okay, and last flip-flop is called T flip-flop. The name of that flip-flop is called what? Toggle flip-flop. Why it is called toggle means, if we are applying the input 0, the output we are getting is 1. And if we are applying the input 1, whatever the output we are getting, that is 0. Means the output is the complement of input. That's why name of the flip-flop is called toggle. Output is changed from 0 to 1 and 1 to 0. Okay, in the T flip-flop also, it consisting of only one input, that is called T, and two outputs are there, Q and Q bar. And again the state is synchronized with the clock pulse. If the clock pulse is present, then we apply the input is equal to 1, the output Q is equal to 0. If apply the clock pulse 1, if the input T is equal to 0, we are getting the output 1. So this is about what? T flip-flop. Is it clear? So this is the revision of our last class. Okay, basic sequential logic circuits are over. Whatever it may be, the sequential logic circuit, always present input depends upon the present output as well as the previous output also. Okay, and see here, now we are going to discuss about registers and what is the need of register and how many types of registers are there. And also now we are discussed about working of 4-bit shift left register, shift right register, and also 4-bit bidirectional register. So bidirectional shifting means it is only the register that is able to shift the data in both directions, right to left and left to right. Okay, so these now we are going to discuss. Okay, see here, first of all, what is meant by register? So the group of flip-flops are connected together to store the binary information is called register. What is meant? Before going to need, while coming to the need, first what is meant by register? So what is meant by register? The group of flip-flops, those are connected to store the binary information is called register. Okay, and what is the capacity of each flip-flop? Is that each flip-flop is used to store one binary bit. Each flip-flop is used to store one binary bit. So while coming to the definition, so the group of flip-flops, those are used to store the binary information are called register. And what is the capacity of each flip-flop? One flip-flop is used to store one bit. For example, if any register consisting of 3 flip-flops like this, one second. Okay, the register means the group of flip-flops is called what? Register. And what is the capacity of each flip-flop? One flip-flop is used to store one bit. For example, if it and see here, while coming to this, so one flip-flop consisting of, for example, if we are going to see one register, I would like to draw one register example. See, this is the register. It consisting of 3 flip-flops. So now this register is used to store 3 bits at the same time. So how many number of flip-flops are there here? 3 flip-flops are there, so that it is able to store only 3 binary bits. Okay, so this is the main theme of register. What is meant by register? The group of flip-flops are connected together is called register. So what is the capacity of register? It depends upon number of flip-flops. If n number of registers are there, it is used to store n number of bits. If 2 registers are there, it is used to store only 2 bits. So in this way, registers are used to store the binary information. And also one more facility is there, that is shifting the data either from left to right or from right to left. Okay, what is the main need of registers? Why we are designing the register? It is used to store the data, and also it is used to shift the data. So what is the capacity of register? The registers are used to store the binary information. Depends upon the number of flip-flops used, it is used to store n bits. It is used to store n bits. Okay, and it is also used to shift the binary data. It is also used to shift the binary data. So in which direction it is used to shift the data? It will shift the data either from left to right or from right to left. Okay, so this is the need of registers. Registers are used to store the data temporarily, and also these registers are used to shift the data from right to left and left to right. Okay, and it is used for the temporary storage of data, not permanent. And the storage capacity makes an important type of memory. So depends upon the storage capacity, the importance must be varied. Okay, so this is about what is meant by register and what is the need of register. Okay, now tell me what is meant by register. Register means the group of flip-flops is called register. And what is the use of register? It is used to store the information as well as it is used to shift the data. It is used to store which kind of information? Binary information. And where to where it will shift the data? From left to right and right to left, it will shift the data. So this is the need of data, and the register will store the data temporarily. Okay, and while coming to the next important one, what are the basic building blocks of registers, shift registers? So here main building blocks of shifting registers are D flip-flops. So why the D flip-flops preferred means the D flip-flop may not provide any operation on the inputs. Whatever the input we applied, that simply passed to the output. Here register, shift register function is also same now. So shift registers are used to only shift the data from one place to other place, not able to do any operation. Like that, here the shift registers will use the D flip-flop. Why? Because the D flip-flops only will do the function of shifting. Whatever the input we applied, that must be appeared across the output. That's why the D flip-flops are used in the shift registers. Okay, according to the horizontal connection, that means left and right. So here the shifter registers are of two types. Means what? Here the already stored bits are moved either from left to right or from right to left. Okay, the bits may be either moved from left to right or it may be from right to left. And see here, while coming to the shifting of bits, it is essential for certain arithmetic and logical operation. Where the shifting is occurred means the shifting is mainly essential in arithmetical and logical operations. And see here it is used for temporary storage between the processing unit and unit requiring this data. And how the shift registers are characterized means the shift registers are characterized by how the data is loaded into and read from the storage unit. How means if the data is entered is parallel means all bits at the same time, then that register is called parallel register. If the data is taken or entered serially, then the name of the register is serial shift register. Okay, in this way the registers must be characterized. Okay, see here. So here depends upon the transfer of data, depends upon the direction. Registers are classified into two types: shift left register, shift right register. So depends upon the transfer of the data, registers are classified into two types: serial transfer as well as parallel transfer. Okay, so among serial transformer, two types are there: serial in, serial out, serial in, parallel out. And while coming to the next one, again two types are there: parallel in, serial out, parallel in, parallel out. Okay, so according to the shifting direction, the registers are classified into two types. What are the two types? Serial transfer, parallel transfer. And while coming to the data transfer, serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out registers are there. Okay, see here, this is the logic symbol of serial in, serial out. First of all, what is meant by serial and what is meant by parallel? See here, for example, if I would like to transfer the data, that is 1001. So in my data, how many number of bits are there here? 4 bits are there. Okay, if I would like to send all the bits by the application of single clock pulse, then that is called parallel data. But now this is the serial shift register. If to send one binary bit out, if one clock pulse is used, and for the next bit and second clock pulse is used, for the third bit more. So like if number of clock pulses is equal to the number of binary bits to transfer, then it is called serial transferring of data. Okay, so the number of bits transferred is equal to the number of clock pulses. So this kind of data transferring is called serial data transfer. Okay, so here the bits must be transferred bit by bit, serially, bit by bit. But cause of serial, okay, cause of serial transfer, here the more time it will require, more delay will be produced. But what is the advantage? Accuracy is there, bit by bit. If we transfer the information bit by bit, high accuracy is achieved. Of course the speed is less, but accuracy is very very high in serial data input and serial data output. So in serial data, input and serial data output register, all the bits are entered bit by bit, and also all the bits are received bit by bit. So that's why the name of the register is called serial in and serial out register. Okay, it requires total 8 clock pulses for transferring 4 bits, 4 clock pulses for entering the data and 4 clock pulses for receiving the data. And see here, while coming to the next one, serial in parallel out shift register. So what is our next one? Serial in parallel out. Okay, see here, while coming to this serial in parallel out, here the data whatever is entered into the register, for example if it is 1001, the data entered bit by bit, means to enter 4 bits the register requires 4 clock pulses. After application of 4 clock pulses, whole data must be entered into the register. But while taking or receiving the data, all the bits must be received at the same time for single clock pulse. Okay, how many number of clock pulses are required to enter the data? N number of bits are there, n clock pulses. In my example, I would like to take 4 bits, so I accept 4 clock pulses. But to accepting the data, if 4 bits also there, if 2 bits also there, even if n number of bits also there, would like to require only 1 clock pulse. Okay, only 1 clock pulse. All the bits are received at the same time. If 4 bits also there, the 4 bits must be received at the same time for single clock pulse. That's why the name of this register is called serial in and parallel out. Okay, so these are the 2 varieties of registers: serial in, serial out, and parallel in, serial in, parallel out. So see here, in serial in, serial out register, to shift to 4 bit, it requires 8 clock pulses, 4 for entering the data, 4 for receiving the data. And while coming to the serial in parallel out, to transfer the same data, it would like to require only 5 clock pulses, 4 for enter the data serially, 1 for receive the data parallelly. So in which one the number of clock pulses will be required? Less number of pulses are there, serial in parallel data. So that here delays also reduced and speed must be increased compared to the serial in, serial out. Okay, so compared to the serial in, serial out, okay, serial in parallel out is how somewhat becomes the speed of operation. Okay, and see here, while coming to the next one, parallel serial out. So while coming to the parallel in, serial out register, all the bits must be, whatever the bits we want to shift, so the all the bits entered into the register must be entered at the same time for single clock pulse. Okay, once see the diagram. So these are the inputs. See here, all the bits are entered into the register at the same time, and bit by bit the data must be received and taken out. Okay, here while entering the data, the number of clock pulses are is equal to the number of binary bits. But here in the next case, the serial data outputs, only 1 clock pulse is required to transfer the 1 data bits. Is it clear? So in parallel in, serial out shift register, all the data bit must be entered at the same time into the registers, and they must be moved bit by bit from the register, so that it requires 1 clock pulse for the entering of data and n number of clock pulses for the receiving of data. Okay, so the number of clock pulses required by the parallel in serial out and serial in parallel out, both are same. Okay, and see here, last one is parallel in, parallel out. So while coming to the parallel in, parallel out register, Here the data must be entered at the same time and received also at the same time for one clock pulse. So what is meant by parallel? In all the bits in binary number must be entered at the same time by the application of only one clock pulse, and also all the bits must be received at the same time for only single clock pulse. Okay, once see the diagram. Okay, once see here n number of bits are used. If n number of bits are used to enter, also require one clock pulse. Okay, and by receiving this n bit also we require one clock pulse. So total how many number of clock pulses are required here? Only 2 clock pulses are required to enter the data as well as to receive the data. Okay, only 2 clock pulses are required to enter the data as well as to receive the data. So this one, in this way, the speed of parallel in parallel out register is very high. Why? Because all the bits must be entered at the same time and received at the same time. So the delay must be reduced and the speed of operation is very high. Is it clear? So depends upon the data transfer. The registers are classified into how many number of types? 4 types. First one is serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So among 4 these, which one is speed? Parallel in, parallel out. And among 4 these, which one is accurate? Serial in, serial out. And among all the 4 these, which one is very accurate? Serial in, serial out. Okay, so this is about the history of registers according to the data transfer. Okay, see here now we would like to explain you about serial in, serial out shift register. Serial in, serial out. So see here the data must be shifted either to the left side or to the right side with the help of the application of clock pulse only. So to design the shift register, here we are using only the D flip-flop. Which kind of flip-flops here we are using? Only the D type of flip-flops are here we are using. See, so here according to the direction, how many types of registers are there? 2 types are there. Shift left register, shift right register. Okay, once you observe the diagram, so here it consisting of 4 flip-flops. How many number of flip-flops are there in construction? 4 flip-flops are there. Sorry. And the direction of data movement is from right to left. The data must be moved from right side to left side. See here. And in construction, which kinds of flip-flops are used? D flip-flops are used. Which flip-flops are used? D flip-flops. And see here how many number of inputs are there for each and every flip-flop? Only one input is there. And how many number of outputs are there? Only one output is there. Okay. And which kind of flip-flop is used to design the shift registers? Only D flip-flop is used to design the shift register. Okay. And here it is a 4-bit shift left register, so that the data must be moved from right to left. It is a shift left register, so that here the data is moved to right side to left side. Is it clear? So which flip-flops are used here? Data flip-flops. Okay. And see, in serial in parallel out shift register, it consists of one serial inputs and output are taken from all the flip-flops parallelly. It consists of one serial inputs and outputs are taken from all the flip-flops parallelly. The data in the register shifts by 1 bit for each clock pulse. How the data is transferred here? See, for the application of one clock pulse, only 1 bit is moved. For example, here I would like to shift the data bits. See here, Q0, Q1, Q2, Q3. So first we would like to select LSB bit. So we consider LSB bit. First the bit Q1 is entered, and after application of first clock pulse, Q1 is shifted to the output of flip-flop 1. And after first we would like to give the data Q3. After the application of one clock pulse, Q3 is shifted here and we are getting Q2 here. And after application of third clock pulse, Q3 shifted here and Q2 shifted here and Q1 shifted here. And after the application of fourth clock pulse, Q3 is here and Q2 across third one, Q1 across second one, Q0 is across first one. Total how many number of flip-flops are there? 4 flip-flops. So the data is moved in which direction? And right side to the left side. So how many number of flip-flops are required to shift the data? In total left side, 4 clock pulse. If we want to take the data outside, how many number of clock pulses are required to take the data outside? Only 4 clock pulses are required. Okay, 4 clock pulses are required. And see here, in shift left register, the data bit is by the bit by bit. In shift right register, here the definitions are there, already I told you, but once see, shift left register, the data must be shifted bit by bit to the left. To left means from right. And in shift right register, that also register, it will shift the data bit by bit to the right side. So right side means from left side to right side, it will shift the data. Okay, this is the definition of shift left register. They maybe come in like a short answer questions in your examination for 1 mark. State shift left register and state shift right register. Shift left register means it is a register that is used to shift the data bit by bit towards left side. Shift register means it is a register that shifts the data right side bit by bit. Okay, of course it may be shift left register or shift right register. Both are designed with help of only the D flip-flops. And here the definitions of serial and parallel shift registers are so there. Once check. So in serial shift register, where 1 bit of information is shifted into register at the same time. Already I explained all this, but once check. So what is meant by serial shift register? Here the data must be shifted bit by bit only. At the same time only one bit is shifted. But in parallel shift register, at a time all bits must be shifted from left to right or right to left. But in the case of shift left register, only if, for example, it consisting of 4 bits, only one bit must be shifted first. After first bit, second, third, fourth bits are shifted. Okay, so this is about what? Shift left register and shift right register. Okay, and see here, this is the shift left register. It constructed with the help of what? 4 flip-flops. It constructed with the help of 4 flip-flops. What are the 4 flip-flops? 4 data flip-flops are there. Once again, so each and every data flip-flop consisting of what? Each and every flip-flop consisting of 4 data flip-flop. Each flip-flop consisting of the input bits 0, D0, D1, D2, D3. And what are the outputs it having? Q0, Q1, Q2, Q3. Total it is used to transfer 4 data bits D0, D1, D2, D3 and Q0, Q1, Q2, Q3. So after the application of clock pulse, the inputs must be entered and output must be taken out. Here the data must be moved from right side to left side. So once check the slide, already I explained the operation, but once you see the slide, the input DN sets up the right flip-flop. Okay, means the Q0 set the second flip-flop, Q1 set the third flip-flop and Q2 the fourth flip-flop. The stored bits move one position to the left when clock pulse is applied. Already I explained. So see here, with Dn is equal to 1, the bits stored as 0, 0, 0. So here they take the example of 1101. So according to this example, Dn is 1, D2 is 0, D3 is 1, D4 is also 1. Okay, after application or the arrival of first clock pulse, the rightmost flip-flop, means the whole data whatever we applied is Q0 having 1 and remaining are 0. But after application of second clock pulse, okay, after application of second clock pulse, the stored word now becomes 0, 0 and 1, 1, 0, 0 and 1, 1. And similarly, like for third clock pulse, whatever the information we are applying is, and according to the direction of shifting data, the binary bit stored is 0, 1, 1, 0. And for the fourth clock pulse, it is 1, 1, 0, 1, 1, 1, 0, 1. And see here that the data transfer in left shift register is Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3. And for the first clock pulse, the output stored is 0, 0, 0, 0. For the second clock pulse, the output is 0, 0, 0, 1. For the third clock pulse, the output is 0, 1, 1, 0. For the fourth clock pulse, the output is 1, 1 and also 0, 1. Is it clear? So this is about what? The truth table of left shift register. The truth table of left shift register. Okay. For the first clock pulse, the outputs are 0, 0, 0, 0. All are 0. At the first clock pulse, 0, 0, 0 and 1. For the second clock pulse, 0, 0 and 1, 1. For the third clock pulse, 0, 1, 1, 0. And for the fourth clock pulse, 1, 1, 0 and 1. So this is about. Next, while coming to the timing diagram. So according to the truth table, for the first clock pulse, all are 0, 0 only. For the first clock pulse, all are 0, 0 only. For the second clock pulse, first one is 1 and remaining are 0, 0, 0. For the first clock pulse, all are 0, 0, 0. Next, for the second clock pulse, it is both 2 are 1 and 2 are 0. For the third clock pulse, 1, 0, 0, 1 and 0. And for the fourth clock pulse, 1, 0, 1, 1. Okay. In this way, from the truth table, we are able to draw the diagram clearly. See here, if it is the truth table, for the first combinations, we draw the truth table like this: 0, 0, 0. Okay, see, for the first clock pulse it is 0, and again for the second clock pulse it is 0, third also 0, fourth also 0, and for the second one it is 0, 0, 1 and 1. Next it is 0, 1, 1 and 0, and it is 1, 1, 0 and 1. So in this way we are able to draw the clock pulses according to the truth table. It is very easy. And see here, now it is shift right register. In shift right register, the data must be moved from left side to right side, left side to right side. Okay, so here the data must be moved from left side to right side bit by bit. So the direction is from left to right. Here we apply the data, means the data must be applied across the left side and the bits are moved to the right side. Except this, everything is same like our shift right register, left register. In left the data move to left, here the data move right, but that is constructed with the D flip flops. It is also constructed with D flip flops. There the data is shifted one by bit, here also. There it works with clock pulses, synchronization is there, here also synchronization is there. Okay. And see here, while coming to theory, in the arrival of positive clock pulses, the stored bits move one position to the right. Here they would like to take one example, 1101. So this is the truth table for the given one. Okay. So here the data transfer in shift right register, for the first clock pulse it is 0, 0, 0 and 0. And for the next one, 1, 1, means for the data 1 is occurred at Q3 register, remaining are 0. For the second clock pulse, it is moved to the second flip flop, all remaining are 0. For the third clock pulse, Q3 is 1 and remaining Q1 is 1, remaining 2 are 0. And finally, whatever the input we are applied, we are getting here, that is 1, 1, 0, 1. So in this way the data must be shifted to the right side. Same, the clock diagram is drawn, depends upon the truth table. It is 1, 0, 0, 0, and it is 0, 0, 1 and 0, 0. Next it is 1, 1, 0, 1, 0, and it is 1, 1, 0 and 0. So according to the truth table, it is very easy to draw the clock diagram. Okay, and see here, our last register is bidirectional shift register. So in bidirectional shift register, it is one which the data can be shifted either to the left side or to the right side. The data must be shifted either to the left side or to the right side. See here, so it combines the both the features of left shift and right shift. And here it is a 4-bit bidirectional shift register. Means what? 4 bits must be shifted either to the right side or to the left side. More than 4 bits we are unable to. Means inside it consisting of only 4 flip flops. And see here, main feature of it is the data must be shifted either to the left side or to the right side at the same time. And it depends on the levels of the control time, that means right, left. See here in the diagram, here main thing is there, here consisting of one logic R by L bar. If R is equal to 1, the data must be moved to the right side. If R is equal to 0, the data must be simply moved to the left side. So depends upon the clock pulse applied to the R by L. So depends upon the clock pulse applied to the R by L control. So here it is called R by L control. So depends upon the data applied to this R by L control, the data must be moved either to the left side or to the right side. If R is equal to 1, then the data must be transferred to the right side, left to right. If R is equal to 0, the data must be moved from the left to right side. Is it clear? So in this way, by the application of clock pulses, the data must be moved either from left side to right side or right side to left side. Is clear? So this is the block diagram of bidirectional shift register. It consisting of 4 flip-flops. For the sake of moving the data from left to right and right to left, it consisting of 2 AND gates, each and every flip-flop accepting the input through the 2 AND gate and also with help of one OR gate. 2 AND gate, all having 2 AND gates and one OR gate. Each and every flip-flop will receive the data with help of 2 AND gates and one OR gate. 2 AND gates and one OR gate. Okay. So in this way it will accept the data. And see here, already I told you, if R by L is equal to, at high level, the gate 1 and gate 4 are enabled and the set of the Q output of each flip-flop is passed through the D input of the respective. If R by L is at low level, only the data must be moved from the left to right. Okay, and see here, this is last one, parallel in, parallel out shift register. So here also it designed with help of D flip-flops. The data must be entered parallelly and also received parallelly. So if whatever the bits were applied here, for example, if 1101 is there, all the bits entered into the flip-flop at the same time. See, D0, D2, D1, D0, all entered at the same time after application of one clock pulse, and all received at the same time by application of one clock pulse only. So that's why this register is called a parallel in and also parallel out shift register. Okay, and see here, while coming to the questions, which of the following is fast? Parallel in, parallel out. Is it clear? Okay, next. Here some advantages and disadvantages are there. So 7415 universal shift register. Okay, which question? A register which can shift the data towards left is what? Shift left register. Okay, and also which flip flop is widely used? Obviously data flip flop is widely used. Okay, in our last examinations, shift to right register is 5 marks question, shift to left is also 5 marks question, and also bidirectional register is also 5 marks question. While coming to the 3 marks or 1 mark, state the need of register or state the use, and state shift left register, state shift right register, all these are the questions. Okay, so now I would like to conclude the class.